Okay, I got some questions about how to do your report and include the calculation on the efficiency of the gearbox that you designed. And so I'm going to run through these calculations that you can modify to fit your situation. Okay, so what we're going to assume here, just so we can put some numbers to the discussion to make it easier to talk about, we're going to assume that the height that we lifted, and we didn't measure that, we should have measured it, but I'm guessing it was about a 2-foot height, so let's use 24 inches. And then let's say we lifted the 1 pound mass in 4 seconds. All right, so a distance, the 24 inches in 4 seconds, that's a speed, distance per time. Okay, so I'm going to assume that you know how to do the calculation. You have a rotating shaft that's spooling up string, and you have to spool up 24 inches of string. I'm assuming you could calculate that to the spool, convert that to the spool speed. Okay, so you'd need that to be in revolutions per minute. Okay, so when I go through that for this particular case, 24 inches in 4 seconds, if I have an effective spool diameter of 0.6 centimeters, that would give me the spool speed being about 485 revolutions per minute. Okay, I'm going to pause here. Notice I said the effective diameter of the spool. When you spooled up your, lifted your mass, the string started with a certain diameter and then it overlapped, and so it ended up with a final diameter. So you need to make an estimate, maybe it'd be the average of the starting diameter versus the final diameter to give you the effective spool diameter to use for these calculations. Okay, so once I have that, I know a certain gear ratio. So we're doing a gear ratio of 0.2. Okay, and from that I could get the speed of the motor. And we're assuming the shaft didn't slip and the gears didn't slip, so there's no efficiency loss due to for the speed. All the efficiency losses with the torque associated with the gearbox. Okay, so if I had gear ratio of 0.2, okay, if I take this 485 and I divide by 0.2, I get the speed of the motor to be 2,427 revolutions per minute. Okay, so once I have that, okay, I know the data sheet. I'd be operating down in here. I could then come up with the tau value for the motor. Okay, so that's just plugging into an equation of a line. And when I did that in this case, I got the motor torque to be 102.5 gram centimeters. Okay, so if we had a perfect gearbox that was imparting all the torque from the motor into spooling up the weight, then we would use the gear ratio to calculate the torque at the spool. All right, so if I divide by 0.2 again, using the gear ratio equations, this theoretically would give me 512.8 gram centimeters of torque at the spool. Okay, so that would be in the perfect world. So we could put an O here for optimal. All right. So what happens in the real world? Well, in the real world, we only have a 1 pound mass. Okay, and then we know the diameter of the spool, so we can calculate from there the torque at the spool also in gram centimeters. Okay, so I use the effective diameter of the spool for that as well. And so if I do a 1 pound mass and use the conversion factors, what I get for the torque that's actually exerted on the spool is, let's see, about 138 gram centimeters. Okay, so you see we should be imparting 512.8 gram centimeters, but we're only needing to impart 138 gram centimeters. So what's going on? Well, what's going on is we're losing torque at the gearbox because of the, it's not a great gearbox. So there's an efficiency problem. All right, so the efficiency of your gearbox is going to be, the theoretical torque that is needed divided by, the actual torque that is needed divided by the theoretical number that the gearbox should have been able to produce. Okay, so when I do that, I get, in this particular case, 0.27 as the efficiency of the gearbox. I just made up these numbers, and so yours might be less than 0.27. Okay, but I'm just trying to walk you through the kind of calculations I'd like to see. Alright, so the instructions say to put this in a spreadsheet. You could just do the hand calculations since we're not going to iterate anything. You could, of course, put all these numbers into a spreadsheet and to do the calculations, but that's not required. We can just have a sheet of paper that shows all these steps as I've outlined here. Okay, so hopefully you'll find that helpful, and I'd like to see that in your report.